What is the Hyperloop 1? The Hyperloop 1 is a system that would transport people up to 600 miles per hour in a tube acting as a vacuum. It would connect Toronto and Montreal. The travel time would be around 30 minutes. This form of transportation would make it very easy to work or do other things in other cities during the same day, as for the low travel time. The benefits of the Hyperloop 1 include the low pressure system in the tube that minimizes air resistance, which means there's less power needed. Can even be powered by renewable energy such as solar energy, as panels would be connected to the tube. Weather would not be an issue as you are in the tube as well. Other uses include the pods carrying items for delivery. Hyperloop is expected to team up with Amazon and FedEx to transport products instead of sending them on a plane, which would be much more expensive and harmful to the environment. Automobile manufacturers should be a big part user in Hyperloop in order to keep inventory low and send parts to distant locations.
And I am doing the price elasticity of demand for the Toronto-Montreal Hyperloop. The price elasticity of demand shows how responsive consumers are to price changes. There are 4 factors that will affect the demand elasticity of the Hyperloop. First off, consumer incomes. Hyperloop will take up a smaller portion of consumer income when compared to a plane ticket. This will make it more inelastic in demand. The second factor is access to substitutes. Planes, trains, and buses are all considered substitutes to the Hyperloop. Either they are more expensive, take longer, and they are less efficient. This would make demand more elastic. 3. Necessities versus luxuries. Time is money. Quick travel times means less time wasted on travel and more time on business or leisure. This will be necessary for business, and this will make the demand for Hyperloop more inelastic. The fourth factor is time. As time passes, more substitutes will be invented, more competition will be around, and this will make demand more elastic. In the short run, Hyperloop will dominate domestic travel between large urban centers. Right now, the PED of North American airplane flights is around 1. I would expect the PED of Hyperloop to be similar to those of domestic air travel because they will have similar usage. And the ticketing system would work like an airlines, with prices increasing and decreasing with the demand for the product. If people are used to buying a good such as Hyperloop, then when prices go up, they will tend to keep buying the good out of habit, but not for long. In the long run, we can see Hyperloop has expanded globally, and for North America, I would expect in the long run the PED to stay below 1 because there is no other competition at the price point of Hyperloop. If the price of a good is expensive for a considerable time period, consumers looking to save money will start looking for other alternatives, such as Hyperloop when you're looking at airplane prices. As long as the prices stay below airlines or high-speed rail, this will create a large target group for the Hyperloop, which will eventually lead to more profits in the long run.
The price elasticity of supply of the Hyperloop. The price elasticity of supply is defined as the responsiveness of a product's quantity supplied to a change in price. In the context of the Hyperloop transportation system, it would be a perfectly elastic supply, as the price would have to remain constant for some time, as the cost of building a Hyperloop system would be very high. So obviously this debt that would be accumulated during the construction of the whole system would have to be paid off steadily by some kind of very steady, fair price for the people using it. Regardless of how frequently the system would be operating, a constant price would have to be maintained. This aspect of the Toronto-Montreal Hyperloop system could be a downside for people considering it, as a high price to use the system may be impractical for some, as a means for daily or even less frequent transportation.
Okay, so this is my part in the Hyperloop project. I'm doing question number 3, so price elasticity of demand for the Hyperloop. I'm going to start out with a chart here, just outlining sort of different ways to get to Montreal from Toronto, and this will be what Hyperloop is competing with if it gets made. So we start out here. This is Hyperloop, $80 a ticket. It's sort of the cheapest one that we've seen. Half an hour, 45 minutes, kind of the range of speed you're looking at to get to Montreal. So that's definitely the fastest. $122 a ticket for the plane, which is second fastest, 72 minutes, about an hour and 10 minutes. $110 for a train ticket, but it's 3 hours 22 minutes. And $83 for a car and 5 hours 24 minutes. And that's just if you have a $400 lease per day, it's like $13 and then $70 for gas. So that's how we found that. Then we go to price elasticity of demand for Hyperloop. So price elasticity of demand is an economic measure of change in quantity demanded in relationship to the price. The assumptions that were made for these numbers are, so we found that 17.6 million people travel from Pearson domestically each year. So domestically is like inter-Canadian flights. About 30% of them go to Montreal, so 5.3 million. And then cars and trains are assumed to be an additional 20 million people. And then that means therefore 25.3 million people will be demanding this service. So that's kind of the pool of people that we're drawing out of. And then we go to this chart here. So this is the cost of a one-way ticket. So this is the range that we use based on how much these are and how much we think the Hyperloop will cost. Number of passengers per year, we just went from 5 to 20 million because we only went to 20 because we're never going to have the full 25 million on our service. And then number of passengers per day, so this is just divided up into days. And then we put that on the graph here, so as you can see 140 per day is about 13,699 people, 120, 100, and then 80. So as you can see, the more expensive it is, the less demand we have because people are more inclined to choose less expensive options such as a plane or a train or even a car. And then the cheaper it gets, more people are going to use it because it's a faster ride. So our 2 points here are 120 and 27,397 per day. And then $100 for a ticket, and then 41,096 people per day. So the math here is that we use the formula to find price elasticity, and so 41,000 divided by 27,397 is 13,699. Divided by 2 is 0.4 times 100 is 40, so 40%. And then the percentage change in price is 100, so 100 for a ticket minus 120 over 100 plus 120 divided by 2 is 0.18 times 100, so it's 0.18, or it's 18%, sorry. And then therefore the price elasticity of demand equals 40% divided by 18%, which is 2.2%. So that's our price elasticity.